Exercise 7. Gas pressures and the ideal gas law. Exercise 1. Explain how the Earth has an atmosphere. Why does the Moon have no atmosphere? The reason why the Earth has an atmosphere is twofold: the Sun and Earth's gravity. The Sun transfers radiant energy to the Earth as sunlight. This in turn increases the kinetic energy of the air molecules. Nitrogen gas, which is about 80%, and oxygen gas, which is about 20%. But the air molecules get a spread in kinetic energy values. The slowest molecules are at sea level, and they have speeds of about 500 meters a second, which is 1100 miles per hour. The fastest molecules to reach the top of the atmosphere is 11,000 meters per second, which is about 2,500 miles per hour. The second piece is Earth's gravity. In order to contain a gas, we need a container. It's Earth's gravity that forms an atmosphere because it stops the air molecules from leaving the Earth. If Earth's gravity was too weak, then the air molecules would all eventually escape into outer space. This is exactly what happened on the Moon, since the Moon's gravity is too weak. Any gas particles on the Moon eventually left, and the Moon therefore has no atmosphere. 2. If you buy a sealed bag of potato chips in Miami and drive it to Denver, where the atmospheric pressure is lower, you will find that the bag gets very puffy. Explain why. 2. If you buy a sealed bag of potato chips in Miami and drive with it to Denver, where the atmospheric pressure is lower, you will find that the bag gets very puffy. Explain why. Miami is at sea level, 0 feet, while Denver is at a much higher elevation at 3,500 feet. Picture-wise, you could imagine that this is Miami, and then if you drive it all the way up to the top of this mountain, let's say, where Denver is located in the valley, then this is 5,300 feet. But this is what we know. At a lower elevation, you have more air above you. But if you have more air, that means you have more air molecules and collisions, which then it provides a higher pressure. Whereas if I'm at a higher elevation, there's less air molecules above me, so therefore I have less air molecules and collisions and therefore a lower pressure. So Miami has a higher pressure region, whereas Denver has a lower pressure region. When a bag of chips is made at sea level, the bag is open to atmospheric pressure. This means when the bag is sealed, the air pressure in the bag is atmospheric pressure. When this particular bag is now in Denver, the inside pressure in the bag is at a higher pressure now than the pressure outside the bag, which is at a lower pressure. So when I look at the picture of the bag of chips, the pressure inside is the atmospheric pressure in Miami, whereas the pressure outside is the atmospheric pressure at Denver. Written out, the atmospheric pressure at Miami is greater than the atmospheric pressure at Denver, so the bag's internal pressure pushes outward, making the bag puffy. 3. Above the liquid in the can of hairspray is a gas at a relatively high pressure. The label on the can includes the warning, "Do not store at high temperatures." Use the ideal gas law to explain why the warning is given. Let's draw an image of the hairspray can. What you're seeing here is that the can, the bottom part of it, is liquid, and then above the liquid I have a high pressure gas. The can contains the gas form of the hairspray, and it is not infinitely strong. That is, it has its limits in strength. If the can is not heated up, then the pressure of the can is larger than the pressure of the hairspray. However, if the can is heated, then the ideal gas law states that if I have a higher temperature, that means I'm going to have more heat energy transfer into the can. But then that means that energy goes into the kinetic energies of the molecules, which is now going to be higher. But if they're higher, I'm going to get a higher internal pressure. When the pressure inside the can due to the hairspray exceeds the pressure of the can will blow up, and of course that's dangerous. 4. A slippery cork is being pressed into a very full, but not 100% full, bottle of wine. When released, the cork slowly slides back out. However, if some wine is removed from the bottle, before the cork is inserted, the cork does not slide out. Account for these observations in terms of the ideal gas law. So I have an image of 2 bottles of wine. Note that I have a brown cork in each of these. This is a full bottle of wine, but it doesn't go all the way to the top, so there's a little bit of air between the bottle and the cork. And this is a half a bottle of wine where there's a lot more air in here. So when I push in this brown cork, note that this is a smaller volume. A smaller volume, according to the ideal gas law, implies that I'm going to have a higher pressure. In this case here, when I press in the cork, I'm not changing the volume as much. So therefore, the pressure change is going to be different. Let's go write this up. For a full bottle of wine, there is a smaller volume of gas particles. If one pushes in the cork, the smaller volume of gas particles will experience a larger reduction in the volume. That is, a smaller volume change implies that I'm going to have a higher pressure acting on the cork, which pushes the cork out. For the half bottle of wine, there is a larger volume of gas particles. If one pushes in the cork, the larger volume will experience a smaller reduction in volume overall. So I have a larger volume. And if I have a larger volume, then I'm going to get a lower pressure acting on the cork, which doesn't push out the cork. It won't push out as hard. 5. Explain how a suction cup works. A suction cup works by changing the volume of the trapped gas. So in purple here, I have the suction cup, and inside here I have trapped gas. So I have these air molecules that are trapped, and the reason why they're trapped here is because the atmospheric pressure is essentially, not letting the air come out. To get the suction cup to stick to the surface, one lifts up on the handle of the suction cup to increase the volume. But an increase in volume reduces the pressure inside. Picture-wise, inside I create a low pressure, while outside atmospheric pressure doesn't change. It continues to be high, so then the atmosphere is pushing the suction cup to the surface. 6. A commonly used packing material is bubble wrap, as the photograph shows. Using the ideal gas law, explain why this packaging material offers less protection on cold days than on warm days. According to the ideal gas law, pressure is directly proportional to temperature. In other words, if I have a lower temperature, then there's less kinetic energy for the particles. This means they have a lower pressure inside, but this implies here that P atmosphere compresses them more. If the plastic bubble is compressed too much, then there's less chance of the package to arrive without some damage to its contents.